Okay, good morning class. So today we're looking, firstly this is our register period. So we'll have 2 maths periods today. You guys don't sound very excited? Yeah, nice. So you guys had some homework, and the homework was dealing with exponents or indices. And we are busy with the first law of exponents, not so? So who can remind us what the law of exponents say? When we multiply, firstly when we multiply, we add the exponents. Okay. So today we're going to carry on with that law of exponents. And probably later on in the next period we will start with the next one. Okay. Okay, so where did we stop yesterday? No, who did we even numbers. So what we're going to do is we're going to just run through it, and then we can see what the issues are. Okay. So I now checked your books yesterday for the odd numbers. Okay. It wasn't really officially marked, so we're going to mark everything now. Okay. So what I'm going to do is I'm going to do all the odd numbers and come back to it for the even numbers. Is that okay? Right. So where did we stop? I think Ilham, what's your first answer? 8 to the exponents. You all agree with that? Next. 6x squared y squared. You all agree with that? Any confusion? No? Next, Isra? 5a to the power 6. You all agree with that? Nice. The next one? Mika? You're right, you must go to the small. Yes? E to the power 6. Well done. You all agree with that? Alright. Next? Here at the back? 20. How do you get 21? Oh, 9, sorry. 20 x squared. Nice. Next, in front of us. That's right, 5a. The power is wrong. For number 11, you got 2a squared times a plus 3a squared times a. So according to Bod mass multiplication first. So what is 2a squared times a? 2a cubed plus 3a cubed. That was a new mistake. Now we are adding like terms now. So what is 2a cubed plus 3a cubed? 5a. When we're adding and subtracting, the variables are the same way. You retain the exponents. Okay. When we're adding and subtracting, the variables remains the same. Okay. So the same goes to the number 11, yes? So this was number 11. Sorry. Number 13, yes? So 6x to the power 7y plus y. So absolutely correct. Who got that sum right? What did you write, Michael? You got it right. What did you write, Michael? 7. How do you get 7? Because this is going to be 3x squared y and 3x squared times 2x 5y plus 1. So you did Bod mass. Is that correct? You applied Bod mass? So what does Bod mass say? What must be done first? The multiplication. So you multiply this. What did you get? Now you see, now you're not doing what you're supposed to be doing. Okay, remember what did I tell you before? You must follow the steps we show you in the example. Okay, the reason why we give you examples is for you to give you an idea of how to do the things. You mustn't do your own thing. Okay? One day when you understand the rules solid, then you can try your own stuff. But for now, you do what we show you. Okay? According to BODMAS, multiplication first. The 3x squared times 2x 5y is going to give you 6x 7y plus 1. Now can we add these here? No, it's unlike terms. Okay? Number 15. Who's next? Yes? You got 24x to the power 8 y. Okay? So wrong. Who got a different answer? Yes?
2x to the power 6y.
That's correct. 2x to the power 6 y. How do we get that? According to BODMAS, what must be done first, my girl? Multiplication. So you must do multiplication first. Amo? Psst. Let's go to Miss Mohammed. You're writing exams. Miss Mohammed. Sorry? You grade 9. Miss Mohammed. Is on that side. Next to Miss Dixon. Okay, so what is 3x to the exponent 5 times 2x to the xy? 6x. Just give her a chance. Don't you want her to learn anything? Don't you want her to learn? Huh? You don't want her to learn?
No, I do.
I think that's selfish of you.
No, sir.
6x to the power 6y minus x squared y times 4x 4.
It's 4x to the power
6y. So are those like terms? Yes. Those two are like terms. So what's 6 minus 4? 6 minus 4? 2. So 6x, 6y minus 4x to the power 6y. So they give you 2x to the power 6y. Okay? So now you made a mistake, so you get another one. Right, go for it. 4. Okay, nice. You all agree with that? Right, next one. Next person. 30. 30. X. Who got that answer? Ilham, what did you get? You got it. Now, why isn't you here now? What did you get, Michael?
I did 30x to the power 5.
You wrote 30x to the power 5. So why didn't you hang up?
Sorry, sir.
You just want to talk to me.
No.
No, then you must put up your hand, man. What's it? Number 6, who's next? Right, you get the chance. Another chance.
16x to the power 5y to the power
16x to the power 5y to the exponent 5. Who got that answer? What did you get, Michael?
So 8x to the power 5y.
Now, how do you get 8? What's 2 times 2? 4. And 4 times 4? 8. 4 times 4, 8. 6. Now, that makes sense. Right. Next. 30. P to the exponent. 8. Who got that answer? Okay, next. Yes, Michael? This is number 10 now. Ne? What do you have? 2AB. Okay, go to number 12. She wrote the sum down wrong.
12 is 14x to the power 8.
14x to the power 8.
4.
It takes power 4 or 8. It's wrong. What are we supposed to be doing first, Michael? What are we supposed to be doing first?
Multiply.
You multiply. So multiply.
4x to the power 2 times 3x to the power 5.
Yes, and what is that going to give us?
12x to the power 4.
12x to the exponent 4, yes. Plus,
2x to the power 3 times x.
which is?
2x to the power 4.
Did you have that in your book? Yes. So what must we do now? Add. Are they like terms? Alright, so add. What do we get? What is 12 plus 2? So what is 12x to the power 4 plus 2x to the power 4?
14x to the power 4.
You see, you wrote 8. You see that? So it's 14x4. Right. Do number 14. What's your answer here?
10 to the power 4.
10a to the power 4b. Who got that answer? What do you have?
I have 10a to the power of 4.
10a to the power 4b. So how is that different to the one you got on the board? So you got the sum right. So why did you put up here?
I didn't see anything. I thought you said 10a to the power of 4.
But
A.
there's a bottle in the way. Okay, just put the bottle out. Maybe the bottle is not. Right, we got number 14 wrong. What did you get, Michael? Make a note here. When adding and subtracting, the variable stays the same. Or when adding and subtracting like terms, the variable stays the same. Because what you have for number 14, you got 2a squared times 3a squared b plus 4a 4b. You multiply that. Now, what did you get? You got 6a4b plus 4a4b. That's what you have, no? Are they like terms? Yes. So what's 4 plus 6? 10. So what's 6 a4b plus 4a4b? So it'll be 10 a4b. So the rule is, when adding and subtracting like terms, did you write this down? When you're adding and subtracting like terms, the variable stays the same. So the unknown here, the variable, remains the same. Sorry? Yeah, I'm gonna get there now. Who's next? Yes?
24
Who got that answer right? Leila, what do you have, sister?
Oh, 24 AB squared C.
But you see here, here's a C and there's a C. So you got two C's. So it's C squared. Okay. Is that it? Yes. Okay. So you all understand, eh? So now we're going to look at so we did multiplication, now we're going to look at division. So now we're looking at division, okay? And this is on page 30. We're on page 30 now, okay? So now we're looking at division. So what does x to the exponent 5 mean? 5 times x. X times itself 5 times. Not so. So it's going to be x times x times x times x times x. Not so. And that's all over x cubed, which is x times x times x. Not so. So what is 3 divided by 3? 1. What is 7 divided by 7? What is 2x divided by 2x? 1. What is xy over xy? 1. So what is xy over x? 1. Then now the x is cancelled. There everything cancels. There everything cancels. Not so. So if you look at what we have here, we see that x over that x will give you 1. So that x cancels. Not so. Or x goes into x once, x goes into x once in the denominator. Okay? The next one. Y, x goes into x1, x goes into x1. X goes into x once, x goes into x1. So the answer is x times x, which is x squared. You all agree with that? Right, now you do for me this one. through that one for me quickly. Guys, finish? Alright, so what do we have here? X times x times x times y times y, y times y times y, over x times y. Okay, so what happens here? The x cancel that x, cancel that x, the y cancels the y. So what are we left with? X, y. That's all. You all understand. Who's confused? What are you confused about? The whole thing. Okay. So you do for me the sum. We have got x2, y3 over x2, y. What do I write on top? And this is all over? So you're not confused about that? Okay, so why are you saying you're confused about the whole thing? Okay, okay. So you're not confused about the whole thing then? No, okay, so you like it. It's a joke, no? It's a joke. Now what? Cancel that x with the y. With the? That x with the y. And this y with the x. The y. So you're not confused about the cancelling either. But you didn't just tell me what I must do. You're giving me the answer. So what's y times y? Well done. Give a round of applause. So what are you confused about? Nothing. Okay, nice. You just want to talk to me a little. Yes, I feel the same. Okay. So now looking at what we have thus far. Okay. Now imagine I'd ask you what would y to the power 100 over y to the power 20 be? Would we write y times y times y 100 times? No. You're going to say it's y 150. Y 100 minus 20, which is y 80. Not so. Because if we look at this here, let's look at the first one. We say, okay, just look at the short method here for number 1. You got x5 over x cubed. What would that be? x5 minus 3. 5 minus 3 is 2. Not are we busy with an x, no? Can you see that, people? So if you look at the next one, the second one, you got x cubed y5 over x2 y. Yes, Michael?
What if they're different variables?
Is here different variables?
No, like I'm talking like different, like x to over y.
X over y. 2 and 3 like that.
Yes.
Then you can't do anything because the bases are not the same. That is where I'm getting to now. You see here, that's x. The 3. What's 3 minus 2? 1. You see there's a 1 here. Y. 5 minus 1, which is 4, which gives you that answer. Yes? Yes! You can do it the long way. But what if you give your y to the 100 over y to the 20? Are you going to do it the long way? No. Okay. Let's look at the third one. You got x2 y3 over x2 y. What do you notice here? x2 over x2. What is x2 over x2? 1. You see now that is the same, so it cancel out. So you got y 3 minus 1. What's 3 minus 1? 2. Same answer. Are you alright? Good, maybe you're going crazy. Alright? But you guys understand? No confusion at this point. No? So let's come to the rule. What if I had x to the power m over x to the power n? If I'm dividing and bases are the same, what do you do to the exponents? Subtract. So this will be x to the power m minus n. That is the second law of exponents. Okay. Therefore, you got x to the power m divided by x over x to the power n is equal to x to the exponent m minus n. In words, when dividing terms with the same basis, subtract the indices. Another word for indices is exponents. So you write that notation, and then we're going to talk about what is this going to be written as now. Okay? Y'all finished? Right? So the sounds out, you guys are ready? So we say that x to the power, or x to the exponent m divided by x to the exponent n can be written as x to the exponent m minus n. So it will be the top exponent minus the exponent at the bottom always. Okay? So it's the top exponent minus the bottom exponent. In words, when dividing terms with the same basis, subtract the indices or exponents. Notation, we are told that x divided by x squared. X divided by x squared. So what we do here is, this can also be written as x to the 10 over x to the power 2. Lots of, which now simplified into x to the 10 minus 2. And what's 10 minus 2? 8. You all understand? Anybody that's confused? Okay, there's a lot of people absent. No, 1, 2, 3, 4. Sorry? Right. There's the next 3 examples. Please settle down. Yes, I'll give you a chance to simplify those 3, okay? Okay, you guys finish? Not yet? Who's confused? Nayasha, you okay? We almost had you again, don't we? Huh? No, you must get a chance. We stop by Layla, must not? So, Nayasha, no. Okay. Nayasha? No. Who got 2 to the power 3? What did you get? In front. Yes.
I want 3a squared.
Huh? For number 1.
Oh, sorry, why? I want 2 cubed.
2 cube. So that means 2 to the power 3. Two to the power 3 is absolutely correct. Why? Because that would be 2 to the exponent 5 minus 2, which is 2 cubed. If you wanted to have it in 8, that's also fine. Sorry? You don't want to go to the x, you said. Okay, nice. Keep the x out of it today, okay? Next.
X to the power 3.
Who got x to the power 3? Okay. That was 4 minus 1. There's nothing there, so it's a 1. X cubed is absolutely correct. Next. Yes? Next. 2a squared b squared. Who got that? 3. Who got 3? The first one is correct. The reason for that is because 3 goes into 6 twice. 3 goes into 3 once. So it's 2. 3 minus 1 is 2. 6 minus 4 is 2. Right, well done. There's the next 3. Who's confused? You all understand what's happening, eh? Okay. Why are you guys laughing? Guys finished? Yes, okay. Next. Is my go? You didn't get the answer. Why not? If you got 3 over 4 like that, can you do anything with it? Then it stays like that. You understand? Who stays? Yes. What's the answer? 3 x to the power 4y over 4. That's correct. But she says she doesn't know what to do with 3 over 4. So my question was to her, if you have 3 over 4 as a fraction, what do? You leave it like that. Who got that as an answer? Otherwise, this could also be have written as 3 over 4 x 4y. That's the same. Okay? But we tend to write it as the first fraction. Okay? So now you get another chance, Michael. You're taking your own time, Michael. But move a bit faster. No? So we're waiting for you to give an answer to us. I think you are overthinking this work. This work is easy. Easy. Right, what's your answer?
X to the power 9, y.
X to the power 9, y z over? Just like it. It's wrong. Who got a different answer? Yes, at the back.
X to the power 9 y z over 2.
Wrong. What do you have in front of her?
2 to the power 9 y is
2 to the power 9. Wrong. Next. Yes.
2 to the power 9 y.
No. Yes.
X to the power 9 y.
Wrong. Yes.
2x.
Wrong. At the back. Yes.
Oh, the power 9 y.
Half to the power of
The power 9.
half the power of x to the power 9. Yes.
Y.
Nice. Well done. Well done. This is how it works. Listen. People, do you think we spend the first time on fractions unnecessary? Yes, you're saying yes. 2 goes into 2 once, 2 goes into 4 twice. So it's 1 over 2. Not so. Now, x to the power 10 and there's your x to the power 1. What's 10 minus 1? 9. So you x9. Or 1x9 is the same. You see as a y cubed and y squared. So what's 3 minus 2? 1. And the z's are the same. So it cancels. So the answer is 1x. You can write it like that. Or 1x9y over 2 or a half x9 1. All of those are correct. Sorry? You were telling me 2 to the 9. You wasn't saying x. Even in your final answer here, you were saying a half to the 9. You weren't saying x. Yes? You gave the first answer.
Yes, sir.
You didn't. Did you say x9 y over 2?
Yes.
Then you're right.
So you cut it off. You cut it away. Yes, sir. You said.
No, but if you start off with 2, then you're wrong. Huh? And yes, she said z. I know she said something else. You said a z at the back. That's why you were wrong. Not oh, it's the z you said. Baby, let's look at the last one. 1. Who got 1? Nice. They're all the same. 1 over 1, which is 1. Okay. So let's look at a few more examples. Yes, the bell will ring now, Michael. What's wrong with you? Are you sure? No. You're always like that with us, man. Okay, since you guys are having problems with this here, so let's look at, just check here, links. Okay, so we're going to look at exercise 9 on page 90 out of the Mind Action Series textbook. So let me just add the page in here. There we go. So there we got a few sums that I want you to do all. The bell rings, you'll just carry on in our maths period dealing with this here. I want you guys to do those two, those 4 sums. Okay. Quickly, no? Yes. Can you see now? So during our lesson we will look at these sums. Okay, we're going to do a bit more on that. We'll cut it so long. Yes? How much of Anderson? Take it and you bring out 10 rand later. Take it too.